Yes, welcome back. Welcome back to EDUHUNT, IIT and NEET Foundation program. This is Sukumar, your chemistry mentor. Now we just completed the types of chemical reactions chapter, the theory part, and with this video I'm going to start explaining the worksheet. Okay, so worksheet number 1, mains model. Let's see the question number 1. Which of the following reaction is redox as well as displacement? Okay, yes, see, it's very easy. See, aluminium when treated with HCl, you'll get AlCl3 hydrogen. Displacement, the non-metal displacement type of redox, hydrogen gas liberated. Here aluminium is displaced hydrogen from hydrochloric acid. Okay, yes. The next, given are the 3 types of reaction in which column 1 and their example is anomalously arranged in column 2. Okay, the point is thermal decomposition. Yes, calcium carbonate. When you heat calcium carbonate, when you decompose something by heating, it is thermal decomposition. And when you decompose some compound with the help of light, it is photolytic decomposition. And you know very well, when you pass electricity through aqueous medium or water undergoes decomposition. At anode and cathode, hydrogen gases and oxygen gases are liberated. So the decomposition of water by passing electricity is electrolytic decomposition. So for A it is 3, for A, and B it is 1. C option is the best, and for C it is 2. Okay, yes. Question number 3. Fe2O3 plus Al gives rise to Al2O3 plus Fe. The above reaction is an example of. Yes, it is an example for displacement. Aluminium displacing iron. Aluminium displacing iron from Fe2O3. Of course, it's a redox type of reaction, but in redox, it is a displacement type of redox. Here, aluminium has displaced iron from iron oxide. Yes. Next, rusting of iron. Rusting of iron is a chemical reaction. The reaction can be termed as, see, in rusting of iron, what happens? Iron from the iron atoms from the iron material combines with oxygen from the atmosphere and other catalyst in the presence of other catalytic acidic medium. Finally, you will get a chemical compound called Fe2O3 on the surface of the rust, on the surface of the iron. So that is called rusting. So basically it is a combination type. It is a combination. Iron element combining with the atmospheric oxygen to give iron oxide. It can be a combination type of redox. Yes. Next, which of the following is a decomposition reaction? Sodium hydroxide HCl gives NaCl plus H2. It's a displacement neutralization type. It's a displacement type. And ammonium cyanide, it's a famous reaction for organic chemistry beginning. NH4CnO. Ammonium cyanide, by heating, there is a rearrangement to give urea. So this is a famous reaction, students. With this famous reaction only, scientists got to know that we can prepare inorganic compounds in laboratory. We can prepare organic compounds in laboratory. So with that idea, today we got such a big branch in chemistry called organic chemistry. So this is an inorganic compound. Ammonium cyanide, it's an inorganic compound. By heating this inorganic compound, there is a rearrangement of this cyanide to give urea. And the next option, third option, KClO3 gives rise to KCl plus O2. Yes, it's a decomposition. Here, potassium chlorate undergoing decomposition to simpler compounds, potassium chloride and oxygen. Which of the following is a decomposition reaction? Third option. Yes. Next, Which of the following is not an example of single displacement? Single displacement means one element which it is going to displace another atom element from the compound. Okay, here aluminum displacing iron, yes. Okay, and here chlorine displacing iodine. It is also single displacement. Here sodium displacing hydrogen, single displacement. And calcium reacting with chlorine to give calcium chloride. It's a combination type reaction. No? It is a combination type. So simply our answer is second option. Which of the following is not an example of single displacement? Ca plus Cl2 gives rest. Yes. Which of the following reaction should be called as single displacement? Again same. So aluminum displacing iron, single displacement. Copper displacing silver, single displacement. Iron displacing copper, single displacement. And sodium displacing hydrogen gas, metal displacing non-metal. Yes. So all are single displacement reactions. Yes. Next question number 8. Take a long magnesium ribbon, heat it over a flame. When burns with a brilliant bright light and is converted into white powder, it's a reaction. See, magnesium when burnt in oxygen gives magnesium oxide. Okay, let's balance this. It's a combination. Here two elements combining to give a compound. It's a combination type of reaction. Yes. Now question number 9. Which of the following reactions should be called as combination or synthesis? Combination reactions can be called as synthesis. See this. C plus O2, CO2, combination type. Here two elements combine to give compound. CaO plus CO2. Here two compounds combine to give new compound. It is also combination type. CaO plus H2O combine to give a compound. Yes, it is also a combination type. But the point is, coming to the case of fourth option, copper plus silver nitrate gives rise to silver plus copper. It's a displacement. Here copper displacing silver from silver nitrate. So fourth one is not a combination type. So 1, 2, 3 are the combination reactions. So 1, 2, 3. Option C is the correct option. Okay? Yes. Next. Which of the following is an example of decomposition reaction? Yes, calcium oxide. See, it is the reverse of decomposition. It is a combination. Second option is the decomposition. Yes, fine. Second option is the decomposition. Next, which of the following reaction should be called double displacement? Double displacement means there are two compounds which are swapping, which are interchanging their components. So silver AgNO3 NaBr, NaNO3 HBr. So double displacement. BaCl2 H2SO3, BaSO4 HCl, double displacement. And BnH2S, yes, double displacement. NaOH HCl, double displacement. So 11th question. So all are 1 to 4. All are double displacement reactions. Yes. Take about 1 gram CaCO3 in a test tube, heat over a flame. When colorless gas comes out, the reaction is, see, when CaCO3, whatever amount you take, CaCO3 is solid and you supply heating, that means when you heat it, it undergoes decomposition to give CaO solid plus carbon dioxide gas is going to liberate. It is an example for decomposition, thermal decomposition reaction. Yes. Which of the following reactions should be called as decomposition reaction? Yes, copper hydroxide on heating gives decomposition. Catalytic decomposition of methane undergoing catalytic decomposition. Yes, fine. When water undergoes decomposition by the passage of electricity, called electrolytic decomposition. That means when you decompose some compound by passing electricity, that is electrolytic decomposition. When you decompose some compound with the help of light, that is a photolytic decomposition. Yes. And calcium carbonate, this is also decomposition. So all the four are decomposition reactions. Yes. Which of the following reactions should be called as decomposition? Yes, decomposition. Yes. Which of the following statement is not true for the chemical equation N2O5 gives rise to 4NO2 plus O2? Yes, 2 mole of N2O5 on dissociation gives 4 mole of. See, for this question, we need a little bit idea of mole concept. I'll explain here. See, here 2N2O5 gives rise to 4NO2 plus O2. So the stoichiometry, the balancing of the reaction, the stoichiometric quotient telling that if N2O5 is taken 2 mole, the NO2 will be 4 mole and the amount of oxygen formed will be 1 mole. Fine, right? But the point is 1 mole of any substance. 1 mole of any substance, how much amount is the 1 mole of any substance will be equal to the mass of 1 mole substance. The mass of 1 mole substance will be equal to the gram molecular weight. So, if it is 1 mole, the gram molecular weight of oxygen is 32 grams. 4 mole means 4 into gram molecular weight. The gram molecular weight of NO2, the gram molecular weight of NO2 will be 14 plus 32. It will be 46. So, the molar mass of NO2 is 46. 4 into 46. 4 into 46 grams. Similarly, this N2O5. Molar mass of N2O5, 2 into 14, 28 plus 5 into 16. 5 into 16. So, 5 into 16 plus 28, it will be 108. So, 2 into 108 grams. So, that is the point. So, now check one by one. 2 mole of N2O5 on dissociation gives 4 mole of NO2 and 1 mole of O2. Yes. According to the balanced equation, that was correct. Yes. Similarly, 1 mole of N2O5 on dissociation gives 2 mole of NO2 and half mole. Yes, if 2 mole gives 4 mole and 1 mole, then 1 mole gives 2 mole and half mole. So that is also correct. 1 mole of N2O5. If it is 1 mole, then this will be 2 mole. This will be half mole, right? See, if it is 2 mole, it will give 4 mole. If it is 1 mole, then this will be 2 mole. In the place of 1 mole, you will get half mole. That is also correct. Now, 2 gram of N2O5 on dissociation gives 4 gram. No. The mole and mass ratio is not going to be same. Okay? Yes. But this is correct. See, I think this is correct. 216 grams of N2O5. I said 1 mole mass is, molar mass of N2O5 is 108. So, 2 into 108 is 216 grams. 216 grams of N2O5. 216 grams of N2O5 and dissociation gives 184 grams. 4 into 48, it is 184. 184 grams of NO2 and 32 grams of oxygen. 32 grams of oxygen. So that is also correct. So A, B, D are correct. C is wrong. Okay. For this you need a little bit idea of mole concept. Don't worry. So the question is here. So that's why I explained.